Hello friends, welcome back to Digitalk. So in the previous session, we have learned in detail about how and where we configure the self-tuning thread pool size, along with how we can monitor the active threads and then idle threads and then your standby threads from your admin console in the traditional consoles like till 14.1.1 and then how to monitor it in the remote console, right, which is from 14.1.2 onwards. Right. And along with that, we have learned in detail about the relation between running threads, idle threads, standby threads, and we have understand with the calculations, okay, how they are completely related with each other. And when we say the default setting of the self-tune thread pool tuning size is 400 and standby is 276, okay, so how it works. So okay, we have learned that in completely in detail with the multiple examples, and I hope now it is clear to you like what is active threads, idle threads, and standby threads. Okay, and how the threads are get transferred between ideal and standby. Right. Just for a quick recap. Right. So we have active threads, we have ideal threads, and then we have standby threads. Right. And what we have learned that 400 is the capacity of the self-tuning thread pool size, which is active plus ideal thread count. And on top of that, we have a standby, which is 276. Okay, and how the threads transferred between ideal and standby from standby to ideal threads, and how this 400 is related with the 276. So this we have completely discovered in the previous session in detail, right? So now what we are going to cover in this session, so in this session we are going to cover the relation with self-tuning thread pool. And what is the relation means? First we will cover the work manager, and the work manager we are going to cover the constraints. So we have a three kind of a constraints in the work managers: maximum constraint, minimum constraint, and capacity constraints. And how this self-tuning thread pool size 400 is related with the constraint, or specifically you can say related with the minimum constraint, minimum constraints, right? So this we are going to cover in this particular session. Now, how we can define the work manager? What exactly is the work manager in WebLogic Server? So your work managers allocate the thread to different requests using certain rules, like the your thread limit and then your constraint. So we have some request classes as well that we will learn in the next few sessions. Okay, so as of now what you can understand that in the work manager are used to allocate the thread to the different applications or to different requests, okay, using rules, some rules. And these rules you can define as constraint: minimum, maximum, and capacity constraint. And let me try to explain it with few more in easy way. Okay, so now what we have learned about the self-tuning thread pool size is it is 400 in the WebLogic server. It is 400 for each managed server. Okay, this is not among all the managed servers. Each managed server has the capacity of 400. Okay, your admin server also has the capacity of 400 threads, right? Which is a self-tuning thread pool. And what we have learned along with that, we have now a single execute queue in the WebLogic server. Okay, which receive all the requests, whether internal or whether external application requests received by your uh, single execute queue, which is has a capacity of around 65K. Okay, so now we have a single thread pool size. And now suppose if we have multiple applications are running A, B, C, D. Okay, there are multiple applications are running in your system. Okay, so your WebLogic is going to treat all the applications in same way, right? So that means the thread is going to be allocated to each and every application from the same shared thread pool. Now, among all the applications, there could be situation out of all applications, one or two application, okay, are the critical one, where you need the maximum availability. You can't tolerate the downtime of these applications or a slowness on these applications, but other can sustain, okay, with a performance issues for some time. Okay, that means you need to identify the priority of your applications, and you identified that application B and application C are very critical. I need the uptime, always uptime for these two applications, right? So in this situation, how you are going to deal with where the all the applications are going to utilize the same thread pool, right? That means your WebLogic is giving the equal priority to each and every application. However, you have some different priorities for some different applications, right? So that means for that you need to define some custom work manager, and specifically the constraints. Okay. And in constraint, we have three constraint: max, minimum, and capacity constraint. Now, what is the difference between maximum, minimum, and capacity constraint, and how it is related with the self-tuning set pool size? So let me quickly explain you that as well. Okay, this is a very interesting topic, and I hope you will enjoy all these things what I am going to explain you here, or what I have been explaining you in the from the previous sessions. Okay, so now let me explain you about the constraints. So max constraint, minimum constraint, and capacity constraint. There are three constraints, okay, that we can define in the work manager. So maximum constraint is the maximum number of threads you can allocate to an application. Minimum is the minimum number of threads that you can allocate to an application, and capacity constraint is the total number of requests, okay, that can be processed simultaneously, or you can say in all total by an application. So what does it mean? So what we have done so far, that we have some applications which is critical, like application B and application D are very critical. I need to maintain the uptime of all this application. So what I can do, from the default thread pool, I can assign some dedicated number of threads will be always available to my critical applications, so that I should not encounter an issue where all the threads are exhausted by some other applications, which those are non-critical, right? So I can define some application specific work manager, and there I can create the maximum minimum constraints, or maybe we can configure the capacity constraint as well, if we have some better idea of the total number of requests that can be queued in your system or can be processed in your system. So with the help of max constraint, you can define the what could be the maximum number of thread that can be assigned to this particular application. For example, application B, okay, I need to define 10 number of maximum constraint, and importantly, what could be the minimum number of threads should be available for this particular application. For example, I would say 5. If I define minimum 5, so your WebLogic will ensure that always there are always 5 number of threads will be available for this particular application B, for which we have created this minimum thread constraint. Okay, so if you have a situation where you have your server is completely overloaded, it's not about overloaded, but it is running under the maximum capacity. Okay, for example, I said the self-tuning thread pool size is 400, and almost 400 number of threads are getting processing the request in your system, and more are coming. So in that case, your WebLogic will ensure the critical application should get their own quota of the threads always, so that the critical request will get processed. Similarly, you have other application which is also critical. So for that, you can also define the maximum and minimum number of constraint, so that this number of constant will always be available for your system. Minimum number of constant or minimum number of threads will always be there for your applications always. Okay, maximum is the maximum number of threads that can be assigned to this particular application. So you are making a certain kind of a restrictions on your applications, so that all the thread should not be exhausted by the a single application or a particular application, or maybe by the majority of applications, right? So we are dividing the fair share, or we are dividing the number of threads to the different applications. Okay, and to identify the number of threads, you need to have a good understanding of your application, the total number of requests that is getting processed in your system by your applications. Okay, what is the load in your system? And then based on the historical the analysis of your thread state, okay, we can conclude the number of thread that is required for your particular application, right? And capacity considered, as I said, the total number of requests that can be processed simultaneously by the particular application to which you are going to define the capacity constraint, right? So the by default, what is the maximum capacity constraint, which is 65K at WebLogic level, right? Your server level. Okay, and then you can define it at the application level as well. Okay, now the important, what is the relation between self-tuning thread pool and your minimum constraint? What is the relation between these two, and which is very important and critical to understand? Okay, so let me explain it quickly. What is the meaning of that, and what is the relation between them? Now, what I have been explaining to you in few lectures, the total number of threads in your self-tuning thread pool size is 400. Self-tuning thread pool 400. This is the maximum number of threads your application can process, or you can say a particular server can process, right? But which is not true. Why it is not true? It can go beyond the 400, but up to where and why? Because if you have defined the minimum capacity constraints for an application, for example, application A, the minimum capacity constant is 5. For application B, the minimum capacity constant is 15. Okay, so what will happen? This 400 thread, which is there in your self-tuning thread pool, what I have been explaining so far, along with the capacity constraints, okay? So it can be a situation where this single thread pool may get exhausted by the multiple applications, right? So what I have told to you, when we define the constraint, we define the number of threads that can be shared out of this thread pool, okay? But that is for the based on the maximum thread pool size. Okay. Now, when we say minimum capacity, that means we have ensured by our application work manager that these number of thread will always be available for your critical applications, and this 400 is the maximum capacity that can go for all the applications. So what will happen in that case? The total capacity, or you can say the total number of threads in your system, if you have defined the custom minimum capacity constant for your applications, would be 400 plus the sum of your all minimum capacity constraints. So in this case, the total number of threads in the system can be 400 plus 5 plus 15. That means 420 total number of threads can be in your self-tuning thread pool size. Okay, self-tuning thread pool. This will be in that case. If you have four capacity constraint, minimum capacity constraint defined for different application A, B, C, and D, and if you have 5 for application A, 10 for application B, and 20 for application C, and again 5 for application D, the minimum constraint. So the total number of threads can be in your pool, self-tuning thread pool will be 400 plus 5 plus 10, 20 and 25, which is 20, 30 and 40, which will be your 440. So this is the relation between your self-tuning thread pool size, along with that the minimum capacity constraint that you have defined for each and every application, right? So now it is clear to you, based on the previous session and for this particular session, the complete relation between your active thread, ideal thread and standby threads, how standby thread pool size works, okay? And then the different type of capacity constraint and the relation between your self-tuning thread pool size and your minimum capacity constraints.